My computer was overheating, it was burning hot, so I Googled ways to cool it down. One of the suggested solutions was to reset the computer, which could help remove any suspicious or unnecessary file running in the background. It took me 3 hours to troubleshoot and restore the system. To be honest, I'm not entirely sure why it got so hot. I wonder if some suspicious software had been installed on my computer. Welcome back to Careers for Youth, a production of Living Game Studio. Today, our conversation will be with Miss Barbara, a computer and information research scientist. Be honest, I am familiar with computer, but still do not know exactly what computer scientists do today to make it more efficiency and innovation. Barbara, let's talk. Please share with me your everyday work as a computer and information research scientist.
Hello, Van. It is nice to meet you. My specialty is in programming languages. My day-to-day work is a mix of deep theoretical mathematics, practical software engineering, and academic collaboration. We don't just write code to build apps. We invent, analyze, and refine the tools and languages that other developers use to build those apps. I spend time designing new type systems that can catch bugs at compile time rather than runtime. For example, figuring out how to prevent data races in concurrent programming, similar to how Rust's borrow checker was developed. Not every language we design is meant to replace general-purpose languages like Python or Java. A lot of my work involves creating highly specialized, restricted languages. For examples, designing a secure, ultra-efficient language specifically for smart contracts on a blockchain, or a language optimized purely for querying massive AI machine learning models. Do you understand what I say?
Wow, there are many technical terms I have not met before. To simplify, your job is to create new program language to help companies to solve their problems.
To put it in the simplest terms, my job is to design new programming languages, or improve existing ones, so companies and developers can solve their problems faster, more securely, and with fewer mistakes. Think of it like this. If a carpenter is trying to build a modern skyscraper using only a handsaw and a hammer, they are going to struggle. My job isn't to build the skyscraper. My job is to invent the power tools, cranes, and blueprints that make building the skyscraper safe and easy.
Programming language and natural language sharing the same concept to communicate between two subjects. Is that true?
A programming language is exactly that, a tool for communication. However, there is one fascinating twist that makes programming languages unique. In a natural language, like English or Mandarin, you are communicating human to human. In a programming language, you are actually communicating with two different subjects at the same time. Communicating with the computer and communicating with other humans. This is the part most people forget. Code isn't just written for computers, it is written for other programmers. When software is built, teams of dozens or hundreds of people have to read, update, and fix it over many years. Therefore, a programming language must be clear enough to tell a story to another human, so they understand why the code is doing what it's doing. You are completely right. It is all about communication. My job as a language designer is to make sure that the language is easy and expressive for the human to read and write, while still being perfectly precise for the computer to understand.
Why can't computer learn language the way humans do? Is there a way to teach them just as we teach a child?
This is the biggest, most exciting debates in modern computer science and artificial intelligence. Computers learn languages differently because their brains are fundamentally different from ours. Scientists are actually trying to teach computers more like human babies right now, though it is incredibly difficult. Can we teach a computer like a baby? Yes! Computer scientists and AI researchers are actively trying to do this. It is a field called Embodied AI and Developmental Robotics. Babies learn by playing and being curious, not by reading textbooks. Computer scientists now write algorithms for reinforcement learning that reward the computer simply for exploring new, unfamiliar things. Humans are born with biological instincts, while computers start as completely blank slates of math. We can simulate curiosity and give them camera eyes, but they don't truly want to connect with us the way a baby naturally wants to connect with its parents.
It may sound complex, but I believe that simulating the human brain to replace a computer brain could yield better results. However, we certainly cannot do that due to ethical and humanitarian concerns. What about simulating the brain of animals such as birds or fish to replace computer brain? After all, as far as I know, we have already gained some understanding of their language.
What you are describing isn't science fiction. It is a real, cutting-edge branch of computer science called biocomputing or neuromorphic computing. Researchers are building drone software modelled exactly on the bee brain. It allows a drone to fly and navigate obstacles automatically without needing a massive, heavy, power-hungry traditional computer chip. The future of computing probably won't be purely electronic, and it won't be purely biological. It will be a hybrid. We will use traditional ones and zeros for perfect math and animal-style biological chips for things like vision, flight, and adapting to the real world. Your idea of looking to nature to solve computer problems is exactly how the next generation of technology is being born. How do you feel about the idea of a computer that is partly alive?
Oh, computer is partly alive. Sound interesting. So human civilization maybe have sisters and brothers, and also arise many social issues such as in relationship between species.
You are thinking 10 steps ahead. And honestly, you are completely right. If we start creating computers that are partly alive, we aren't just talking about tech support anymore. We are talking about a whole new branch of philosophy, ethics, and law. You joked about computers becoming like our sisters or brothers, but sci-fi writers and serious philosophers are already debating the exact social issues you just foreshadowed. Who is responsible when it makes a mistake? A funny thought to leave you with. Right now, when a computer gets a virus, it just means a bad piece of software code. But in the future, if your computer is partly alive, you might literally have to give your laptop a dose of antibiotics or a cough syrup if it catches a biological cold.
What is your current program language? Are you researching or still in a paper now?
Large language models are great at guessing text, but terrible at strict logic or math. Traditional code is great at strict math, but terrible at understanding messy human context. This is a major boundary in 2026. Researchers are publishing papers on languages where you can write a standard function, but inside that function, one of the steps is a call to a neural network. For me, if you looked at my desk today, you would see papers trying to solve one ultimate question. How do we build languages that allow humans, traditional computer logic, and unpredictable AIs to safely talk to each other without crashing the system?
It is very interesting to talk with you about your work. Now let's move on to the fun session of today's conversation. I had the music library Every time I key in the keyword in the search toolbar, it will come out a song to listen. Now, let's try your job in a few words. What would you say?
Teach computers and robots how to understand us.
Okay, I will key in these computers and robots how to understand us in the search toolbar. And here a result. Oh, this is the fun song. Barbara, thank you for taking time for come here for the interview. I wish you a good day.
A long term ago in the future, Oren is a computer teacher. Oren doesn't have children but a tiny cat. Oren is sharp as a tack and bright as a button. He understands poetry, code in the sun. Besides the cat, he also raised a team of robots. The team is pretty smart and working hard. Their everyday task is roast coffee, clean and take care of the cat. One tired and hard-working day, Oren comes home and he forgets to shut down and reboot the computers. This simple task make the robot teams work non-stop and feed the cat with a huge amount of water and meat. The cat run out of the house under the scorching sun. Out of control, and still don't know how to let the team stop working. Oh, why? Oren yell at the mad robots, mute the computer, and run out to the beach under scorching sun. Eventually, Oren find a code to deactivate the command, and the robot team slowly comes home and take a rest. That is Oren's story long time ago in the future. Welcome to the field!
Friendly reminder that today's episode is just for fun and education. Definitely chat with a career advisor before making any major decisions. Shout out to the US Bureau of Labor Statistics for the awesome data that help us put this together. This event and artificial intelligence. Thank you for listening, and I will see you next time.